may not be there anymore, and so they're poorly understood, and there's a lot of quirks, and so you know, it's not just about applying machine learning, it's all steps that get to that. But as we put these systems into place, while they're good from that perspective, you know, there is a loss of control and visibility into the inner workings that comes along with that. Stephen touched on that briefly earlier, especially as you get more advanced. You know, when you push into deep learning, with auto feature engineering and things like that, not only do you not really have great visibility into decision logic, you don't even understand kind of what the inputs to the whole equation are well. There's techniques for dealing with that, but it's a challenge. And the other thing, you know, layered on top of this is businesses, especially if you're like me, you work in heavily regulated spaces. You know, there's a real need to understand why decisions are made, what's going on with these systems. You know, when the regulators come to talk to us, we can't just say, "Oh, we don't know why we did that. It's just what the boss told us to do." I assure you that does not play well with the government regulators, and it shouldn't. And even internally, you know, we want to understand those decisions because many times, like understanding why the conclusions have been reached really drives our strategy. So it's important to know that. So as we deploy these systems, you know, we need to do it in a way that is well managed for our business. And there's some common errors that we see, you know, common categories of errors that we see over and over again, a real range of them. So some of the most pedestrian ones are just simple logical errors, right? Overfitting and underfitting of models. Anyone who's done anything in machine learning kind of understands as basic and fundamental as this is, getting it right is tricky. We see the errors bringing stuff into production, right? So a lot of times as data scientists, we develop this perfect model that's operating beautifully in our clean room lab. And then we go to deploy it to the real world, and things often get a little messier. And one of my favorite stories about this, I was actually talking to a woman about 3 months ago who had recently won a data science hackathon. And this particular hackathon was centered around predictive factors for like susceptibility to breast cancer. They had this really rich data set that had been anonymized. And as the different teams were feeding this data and coding it into their algorithms, this one researcher, this one woman had decided to, on a whim, to put the randomized ID in there as well. And so when they actually went to evaluate the contestants, she got 100% right and won hands down. But it turned out later, unfortunately, she was using an algorithm that could actually give some insight into which factors were most predictive, something like random forest or one of those. So when they took a look at it, they realized that randomized ID for the different patient subjects was actually not that random, and into that had been encoded whether the people had, you know, the labeled data set. And so while she worked, she won the contest, and it worked 100% of the time in the lab. That's obviously a result that does not translate into the real world. Next up is a really common one, temporal data drift. We see this all the time. So this is things where over time, your inputs to your model are going to change. And so that can be, not in all cases, but in many cases. That can be everything from seasonal variation, weekly or other periodicity, to kind of macro trends like changing economic conditions and consumer sentiment. And so for a variety of reasons, the model that's just yielding unbelievable accuracy today, you can't just put it out there and expect it to continue to achieve those same great returns over time. And you need to watch that because sometimes that data drift can happen quite rapidly. So it's not always a regular cycle, and you need to make sure you're aware of it when it happens. And then the last big category we think about is poorly understood data. And this can be for a variety of reasons. Sometimes this is because the data is poorly documented or someone didn't read the documentation. A lot of times these data sets have little to no metadata with them. It frequently comes from quirky legacy systems, as I mentioned. You know, a lot of times for mature established businesses, the core business systems that they're using data from have been around for a long time. There's one in Capital One that is kind of famous for this. One of the features in it, one of the attributes in the data is a value that is typically a positive continuous variable, but like every once in a great while there's some deep corner of the business logic that spits out a -1 for a stop value. And the number of kind of, you know, of data scientists who've spent some time scratching their head wondering why their model keeps making bad decisions in a few cases, like laughably bad decisions, has been a source of amusement at us, but at Capital One, and so that's kind of led us to get better at metadata and documenting and understanding our data well. So that's four major problems. There's definitely more, and all these problems are long before we get to this guy. This is tongue-in-cheek. Please no one tweet out that Capital One is developing a fleet of robot cyborgs to take over the world. This guy, that's a long way off, and machines are nowhere close to developing an approximation of sentience. But we are already starting to see cases where machines are starting to approach life and death decisions, whether it's self-driving cars, obviously in healthcare, automated diagnoses, things like that. We're starting to get there. Unfortunately, there's still very strong human-in-the-loop mechanisms, but it's something we all need to think very carefully about because that trend is only going to accelerate. Let's switch to a much more positive way of thinking about this, and this is the way I view it. And are there any Formula One fans here? There's a lot of people. I'm sure there's some. Thank you. There's quite a few Formula One fans here. So, for people who have followed Formula One over the last 20 years, there's been some really interesting developments in technology. In driving, just like machine learning, there's all sorts of guardrails that get built into cars. Not so much guardrails on the road, but ones that actually get built into cars, right? So, things like anti-lock braking systems. Well, anti-lock braking systems keep us safe. We're all really thankful to have them in the cars we drive. When they go to roll these kind of things out in Formula One, here's what happens. It allows the race car drivers to get a heck of a lot more aggressive. So anti-lock brakes means they can carry a lot more speed in the corners and brake later without fear of getting set off the track. Or, launch control systems, which came out, I don't remember, about 10 years ago. The first cars that had launch control systems, they're just almost comical clips of the beginning of races where there's a couple people who had launch control systems just shot by the rest of the field. And what launch control systems do is literally you just kind of mash on the accelerator and the computer will figure out how not to turn your wheels into a pile of into liquid rubber by spinning them out, but actually how to get all that down. And so, these are all, and traction control systems are the same way for taking turns as fast as possible. Just let the computer kind of mitigate, in an automated way, mitigate that risk. So, I think this is a great example of ways that these risk controls aren't just there to be responsible and satisfy regulators. They're actually there to help us move faster. We can kind of put the pedal to the metal more with our machine learning efforts if we're confident that something's going to bail us out, that we're not going to go into the wall or into the runoff area if we get a little bit too aggressive. And so, we talk about predictive analytics. This means, right now, a lot of people, there's a lot of interest in developing automated model pipelines where retraining your models and refitting them and then redeploying them very aggressively is depending on the use case, can yield tremendous results, whether that's weekly or daily or hourly or 5 minutes or continuous learners. We see actually, some use cases where that really aggressive update cycle makes a big difference. And it's specifically in cases of adversarial machine learning, where you have teams of adversaries working on the other side, so you can think about like fraud or cybersecurity use cases or a number of others, that are actively evolving their tactics in real time against you. We want to incorporate those learnings in your model as you deploy it. But that's kind of, that's something you have to do carefully, right? Because if you're retraining and refitting your model, it doesn't take, every 5 minutes and pushing it out into these production systems that have big impacts on your business and your users and things like that. You should be very careful to make sure that you have these safeguards in place. But if you do, you get massive benefit out of it. So I think for us, like everyone in this room, I think the people in this room really represent the leadership, thought leadership in machine learning. The people who are attending are the ones who are going to be driving this innovation forward. And so I think as we all implement our own ML strategies, the initial push right now is just to kind of get ML stood up and running and kind of get in the basic forms. But we all need to be thinking about how we do it in a kind of well-controlled manner. Because ultimately, it's not only safer and smarter, but it's going to allow us to move forward more aggressively and really kind of be a strategic advantage there. So I think, I really view it as a challenge for us all. Is how do we invent new ways to responsibly deploy ML so we can move faster? Something we take very seriously at Capital One. As a matter of fact, just because we believe it so strongly, we're going to be releasing some stuff in the next few months, a white paper and some open source projects, around that and how we kind of monitor models and build them and deploy them so that people can, it's really, we look at it as the beginning of a conversation with the community. What is the best way and the most effective way to do that? I think that's really going to advance the state of the industry, and we're very excited about that. And I think having venues like this, and thanks George and the team for organizing this, a great venue. I've had a lot of great conversations here already, but I really welcome these opportunities for us all to kind of come together and talk about managing that stuff effectively and how we do machine learning responsibly. Thanks, everyone. We'll time for a couple questions. Thank you.
Yeah, let's take time for a couple of audience questions if anybody has any. Right back here. We have here's a microphone over here.
Right here.
Right in the back.
Yeah, can you hear me?
Yes.
Okay. So my question to you is, how will your deployment of machine learning in Capital One brings value to the customers?
We have, like a lot of companies, we see use cases all across Capital One. I got to be careful about what I comment on specifically, but just like a lot of other people with massive customers, you can think better fraud, right? We've all been annoyed by having our credit card deactivated because of suspected fraudulent transaction. There's a lot of research going on right now into better user customer service experiences by automating that. We obviously use cybersecurity. There's a number of areas that we see it. So I think there's nowhere that we don't see as ML kind of moving the ball forward inside Capital One.
I was just wondering because I think customers need to feel some benefit or a value out of what you're providing to kind of like,
yeah,
your
I think that's a good point.
competitors. So there is no difference, and we could spend millions. So I come from HP, and we constantly evaluate whatever investments we are doing, whether it's AI, machine learning, predictive analytics. We need to see what kind of value I'm bringing to customers for them to really like it.
I agree. I think there's a danger there that if these systems, like customer service systems, get deployed too quickly and they're not done well enough, then people are going to start to get frustrated by these activities. Like the old, we've all been on those voice response systems where you're like trying to yell at the phone and get it to do what you want and it won't listen. And we're trying not to recreate that with ML systems, customer service bots, that kind of thing. So, I think that there is we need to be cautious about how aggressively we deploy the technology that humans, the general public has to interact with. Because obviously you can create a very frustrating experience if you don't do it correctly. That's not good for anyone. Like I mentioned earlier, random forest is pretty good at giving you some indication of like which factors are the most predictive and kind of giving you a general importance level of features. And there's other ones that do as well. Whereas deep learning, is not as good at displaying that. For the areas what you often see as you kind of climb the maturity cycle for machine learning systems is ensemble approaches take on, generally most mature systems take on an ensemble approach. And so if you were, trying to recommend, shirts, maybe there's rather than just having a shirt recommender model, you'll have one that's based on the color recommender model and the fabric recommender model, the pattern recommender model, and you'll have a real ensemble of these models. And so while maybe each of these models individually is kind of opaque, you kind of start to approximate, hey, why was this shirt recommended to me? Well, it was recommended to me because it's similar in color to other ones you've liked in the past. And so I think there's a lot of work you can do with taking that model approach where you're not just saying, hey, recommended that shirt, but provide that explainability that way. But I think it's a fascinating topic and one that takes a lot of work to really think through.
Great, thanks so much, Adam. I think that's all the time we have for questions now, but I would certainly encourage you all to catch Adam sometime during the course of the day with anything you'd like to discuss with him.
Yeah, I'll be around. Thank you.